Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 14th. Current significant wave height data for the North Pacific Ocean suggests seas in the near 24-foot range off California, part of a previous system that was over the dateline generating higher seas. This has produced swell that is currently hitting Hawaii and about poised to reach California. Otherwise, a generally not very impressive pattern is in effect. Let's take a look at the details. First off, let's take a look at the jet stream. Jet stream level winds, these help promote the formation of storms, and when those storms do form, help direct their path. Currently, we have a very healthy flow pushing off Japan. Notice this, almost 180 knot winds pushing off Japan, arching over the dateline, and then getting ready to fall into a developing trough in the eastern Gulf of Alaska. A little bit of a split pattern is going on here, though with most energy pushing into central California, a little finger of this pushing up into Alaska. But generally speaking, the entire North Pacific is open for business with lots of energy in play, no real split jet stream happening. This is all supportive of gale development. Let's put this into motion. As we proceed into Monday, the basic same pattern develops. The trough getting better defined off of California, Central California in particular, and solid winds across the entire North Pacific Ocean. This rolls out into Tuesday. The trough moves onshore. Notice a new pocket of winds building here over Japan, and a little bit of a trough trying to set up here on the dateline. So this trough here supports a gale. This trough, if it develops, would support yet another gale, and yet there's more energy building behind that. And sure enough, as we get into Wednesday, a new trough develops on the dateline, pushing towards the western Gulf, while this trough here, the first one, pushes into the U.S., and winds build to 200 knots off Japan. All this looks very favorable. We continue rolling it out. We're into Thursday. The Gulf trough, or the western Gulf trough, moves up into the Gulf proper, and yet a new trough starts developing just south of the Kuril Islands, this on Thursday. That trough continues. It's broad, kind of weak, but there's a lot of wind energy here. That'll support low pressure development down at the surface. Continues to the dateline on Friday, and then continues east from there. Notice this, a broad, drawn-out dip in the jet stream. That would support this counterclockwise circulation down in lower levels of the atmosphere. That is low pressure or gale, if not storm development, into Saturday now. And we roll this out, and it just keeps going. In fact, the trough gets even better defined going into Sunday, and here we are 180 hours out into almost Monday, a week from now. This all looks very good, and yet more wind energy in the jet. This is typical either active phase of the MJO in wintertime or El Nino sort of pattern. No real splits, lots of energy, good well-formed troughs, definitely supportive of gale development. The next week looks favorable at the upper atmospheric level. Let's go take a look down at the surface. So here we are, looking at surface level pressure, surface level winds. Notice high pressure, 1028 millibars, just sort of a moderate level high pressure north of Hawaii, driving trades, and certainly our trades are a little bit too northeast in the Hawaiian Islands. Then we have low pressure of sorts trying to get organized here off the California coast. South winds are in effect in central California with light rain already falling, the next front in a series moving into the coast. Roll this out here. We're into Monday. South winds move completely into California, north of Point Conception. Rain is in effect. But looking back, we see a giant area of low pressure, but no real organized vets. Bits and pieces of 30-knot winds, but nothing really steady over a large area to generate seas and or swell. But we roll this out, and here we go into Tuesday. Sure enough, a small gale develops on the dateline, 45, almost 50-knot northwest winds here, sort of targeting Hawaii initially, and then 55-knot winds by Tuesday morning, aimed more to the east. This sets up probably swell mainly for the U.S. West Coast, but sideband swell into Hawaii. Notice this continues on into Tuesday night, into Wednesday, and for the most part stays south of 45, which really is favorable, 45 north, favorable for California indeed, and then eventually lifts up into the Gulf and fades. But notice right behind it a very large low pressure system. Now, not all this is supporting real fetch aimed at any of our main targets here. It's mainly this pocket of winds here, 40 to 45 knots. Thursday continues though. definitely aimed at Hawaii and covering a good size area with his secondary fetch, but that's aimed mainly more up into Alaska and Canada. Anyway, the main fetch continues into Friday, and then additionally gets re-enhanced now into Saturday. This is new, just on the models this evening. And 45 knot fetch continues into the Gulf of Alaska. Basically, we're into there we go. It fades out on Sunday, so almost a week out, and then high pressure starts building. That's 1034 millibar, 1036 millibars on the date line, a week out. So that would suggest perhaps a pause in the action, but there's no shortage of low pressure even behind that. So we'll have to see. Right now, surface level pattern looks good. Let's go take a look to see what effect those winds will have on the ocean surface. So here we go. Significant wave heights for the North Pacific Ocean. We're actually going back in time to Wednesday. We're not so interested in this area here. Swell from all of this has already hit California. For the most part, it was stormy, except into Saturday and Sunday, but that's already gone. It's the gale here over the date line that developed on Wednesday. We'll just roll through this real quick. Swell from this system has already hit Hawaii and is on the downswing. We're more interested in the effects on California. Notice 42-foot seas. Here you go on about the 288-degree path relative to Northern California and about the 293-degree path into Southern California. And notice this. We'll put the Great Circle paths here. Notice the sort of arch and then the flat track here. Notice how this storm progresses. It basically follows that exact track. Here we go. We're into almost Friday, 36 and 37 foot seas. Then it slowly faded out into Saturday night. And now here we are. We're current time right now. This is the remaining seas poised to hit California, and some small energy from the swell is already starting to hit Northern California with periods in the 22 seconds, in the 2 foot at 22 second range. Anyway, let's take a look and see what's coming in the days ahead. First off, the gale developing over the dateline, a small system, 40-foot seas on Tuesday morning, and it builds to, about 36-foot seas. Relative to Hawaii, this is on the about the 330-degree track or so. You actually go back a little bit, and you get a small little bit here on about the 320-degree track, but most of the energy is in the 330-degree track. But also notice this system is moving this way, and the swell vectors in here are sort of almost pushing northeast. That sort of means only sideband swell relative to Hawaii. But relative to Northern California, here you go, 292-degree track. Following that, we'll just roll this right out. Gets up to is about 38-foot seas on Wednesday on the it's about the 296-degree track, and that's good for Northern California. For Southern California, a little bit further to the north, 301-degree track, a little bit too far north to be ideal for Southern California. Anyway, that system works its way pretty well into the Gulf here, and then finally fades out. We'll say Thursday morning. That's the last position we'll really look at, and that's 302-degree track with a little bit of energy here right on the south end of it on the 296-degree track into Northern California. And relative to Southern California, well, there's the 301-degree track, so most of the energy is north of even that. But also notice, new gale developing off Japan on Thursday, covering a pretty good amount of size, 38-foot seas, working its way over the date line. Now, relative to Hawaii, this is a good one because it's, well, actually put this back. Watch this. It's tracking much better up the Great Circle paths into Hawaii with 38-foot seas and relatively close by at that. If we can do this, there you go. 1,600 nautical miles, 309-degree track, and we'll even go back early when the system there is about when it peaked out right there. And that's just roughly speaking, about 2,374 nautical miles on the 302-degree track. So west swell for Hawaii if this system develops as expected. And then it starts moving past Hawaii and fading only to redevelop. And now the energy, I think, is going to become more focused on Hawaii. That's 297 degrees there. But then it's 40 degree, look at that, 40-foot seas, and actually dipping a bit south. So here we go, this is a bit confusing, but some energy into Hawaii on about the 330-degree track, and then also for California as well. continuing east from there and fading out. So actually, let's go put this back, do a quick check here. And about 1,468 nautical miles from Hawaii on the 336-degree track, and also into California, but still 2,243 nautical miles away, 296-degree track. Anyway, the system is to continue east and then fade out. The likelihood of swell looks good for both Hawaii and California, but this system's a long way from forming yet. But still, notice, here we are, even 180 hours out, large area, 25-foot seas off California, certainly piles of fetch aimed at Hawaii. So this will be an interesting system. And what's even better is the suspicion is maybe high pressure is going to start building off of California. That might sort of deflect some of the energy from the storm north. The issue lately has been that there's been a lot of weather coming in with all the swells into California, and the better part of the swells literally have just been buried in south chop and rain and wind and not really rideable. So something to look forward to. Now let's take a look at longer-term projection. So what we're looking for is the presence of El Nino, or at least the presence of the active phase of the Madden-Julian oscillation. And the MJO, for short, typically when it's in the active phase, it helps support storm development in the North Pacific during winter months. So what we want to see is negative numbers here. That means lower pressure at Tahiti, higher pressure at in Darwin, Australia, and that suggests the active phase of the MJO. Right now, we've had a pretty good run of negative numbers, not as low as it's been, but still steadily in the negative territory. Here's the 30-day running average. Take 30 of these, average them up, and here's what you get. And so we're at minus 5.48, and then the 90-day average. This really is less a sign of the MJO and more a sign of El Nino. If you get 3 months in a row of negative numbers, which this is suggesting almost down at 0.7, and it's been hanging in the 0.7, minus 7, minus 8 range for since mid-October now. So this is suggestive of some weak form of El Nino. So all this is good. Let's continue looking. Another indicator of the MJO, the active phase of the MJO, or El Nino, is the presence of westerly wind anomalies in the Pacific on the equator, just a couple degrees either side of the equator. Here's Australia, Asia's here, and what we see here, and these are differences in wind direction and speed from normal for this time of year. What we're seeing right now is easterly anomalies. That is not suggestive of the active phase of the MJO, not suggestive of El Nino, will not support the development of Kelvin waves, and so pretty much that's not particularly good news. And those anomalies continue to the dateline, but then notice here, right just as we approach Hawaii, some westerly anomalies, and the chart continues here. Here's Hawaii right here. There's Mexico there. West anomalies, yeah, in this area, you know, that could help at least support some continued push of warm waters down under the surface. And we'll get into this in a minute. We're looking for the formation of Kelvin waves. Those are the hallmark sign of El Nino, or at least developing El Ninos, and they can even occur during the strong active phase of the MJO. And looking a week out, still easterly anomalies over the maritime continent. Notice this. High pressure, strong high pressure. We saw this on the charts a week out. So forecast to build over the dateline. Even to some extent, it's supposed to get some traction down on the equator. And then south of Hawaii, a neutral pattern. So nothing really stands out here that suggests that El Nino is pumping or the MJO is pumping or anything, though the jet stream looks quite good. But what this also sort of suggests is more of an early indicator. The jet stream is more an indicator of what's been happening. The indicators can change here down at the surface rather quickly, and then the jet stream can respond in kind. Next we look at, this is a MJO indicator, outgoing long wave radiation. So what we're looking for, yellows and oranges are symptoms of clear air, high pressure, typically easterly anomalies. The blues are westerly anomalies, clouds, and the active phase of the MJO, this the inactive phase. So currently we see some sort of a weak active phase of the MJO on the date line, and all these, they track west to east in roughly 3-week durations. So we see the weak after effects of the active phase of the MJOs fade out about a week out, and then here comes the inactive phase working its way into the West Pacific over the next 2 weeks, 15 days that is, while a new active phase builds in the Indian Ocean. Now this is the statistic model. The dynamic model shows something similar. Here's your inactive phase. It sort of loses it here, but then it has it moving into the West Pacific and stronger. Here we can actually look at both models. See, the statistic model shows some strength, the dynamic model more strength. Both show the active phase rebuilding. So what this means is about 2 weeks out, it wouldn't be surprising to see the storm track take a break over, let's say, the Christmas holidays, and high pressure build in. Probably some of the snow making machine shuts off as well. The storm production backs off some, but then the expectation is when the active phase of the MJO works its way into the Pacific, probably a month out, then things will start hopping again, and you'll have let's say a 2 to 3 week run of swell production. In fact, let's go take a look at yet another model, further longer duration 40-day upper level model. The yellows and oranges here are again the inactive phase, the greens are the active phase. What you see is sort of a weak active pattern fading out through January, with the inactive pattern really starting to, this is very weak, pretty much holding into about January 5th, and then it falls apart, and the active phase then starts building in the West Pacific in January or so, but probably not till about the 15th of January, towards the end of January, that things start to wake up. But again, all this is a very, very weak signals, not strong, and that's what you'd expect to see during El Nino. That is, the MJO sort of dissipates, fades away. You just sort of live in this persistent, weak, what would be considered an active phase of the MJO, and there's not a whole lot of variation. I wouldn't be surprised to see these models back off over time, especially looking at the upper level model. Next, we're going to take a look at sea surface temperature anomalies, that is, differences from normal for the time of the year. Notice we're back in February of this year, and we want to highlight how the ocean has changed, and specifically this area. If you draw a box right from about here to about here, this is the main area that is monitored for the presence of El Nino. Blues are colder than normal, yellows, oranges, warmer than normal. You're just going to hear me clicking away here. We're going to go through, watch this. And so notice we had cooler than water temperatures here, and then we're into March, and all of a sudden water temperatures start warming up, and rather nicely. Notice this, especially off of here, Ecuador. Warm water builds, the result of Kelvin waves, and we'll get into that in a minute, hitting off the Galapagos Islands, but also a big pool of warm water here, and notice it's sort of drifting this way across. So we'll continue to put this in motion. Look at that. It looks like that's almost a classic El Nino symptom, but then boom, you get into August, it all sort of falls apart, but just for a week or two, and then all of a sudden the warming starts developing, and now we're into October, and it's getting solid. Notice the pulses of red and warm are starting to work their way across the equator here. And actually, we'll go back a little bit just so you can see this, guys. It is actually pretty impressive to see it. So September, and here we go. Just put it back into motion. Here come the pulses working their way across, and we're into December, and there you go. This is our current state. Warm water across the entire equatorial Pacific, and of course up the U.S. West Coast. But the area you're really interested, you can look at this whole area, but specifically this area right here, and we have warm water in play. This is a good sign. This is the key indicator for El Nino. The warmer this water gets, the more impact it has on the atmosphere above it. It changes the circulation of the atmosphere, but in essence what it does, it starts pumping the jet stream. The jet stream then starts fueling storm development. Storms create fetch. Fetch creates seas. Seas, as they decay and move away from the fetch that created them, result in swell, typically in our main forecast areas, Hawaii, U.S. West Coast, but in fact, the North Pacific swells work their way down into Central America and other places as well. So right now, the pattern, sea surface temperature-wise, looks pretty good. Here's another view. So this is actual sea surface temperatures, actual wind directions, but here's anomalies from normal. Again, notice this is just a couple degrees either side of the equator, and going from the whole, this is the whole width of the Pacific Ocean. What we're really interested in is this area bound right in about here. Notice we have 1.5 degree anomalies in the far east Pacific, 1 degree anomalies here, and half a degree or so spread over that area. So the previous animation that we looked at is a broad level view. This is a little more detail. This is confirmed by buoys on the ocean surface here. Also notice wind anomalies, pretty much neutral along here. A little bit of pocket of easterly anomalies, 160 east out, but nothing too strong, just kind of a neutral thing going on. But it is not so much the surface temperatures that we're interested in. The sea surface temperatures on the equator are really a symptom of what's going on under the ocean's surface, about 150 meters down under the equator. And here is that view. So here is absolute surface temperatures. Okay, this is 140 east, so you're over by New Guinea here. The Galapagos roughly here. We're looking down under the equator, just a degree, 2 degrees either side of the equator, and looking at the temperature profile here. And this is the anomalies from normal. And notice this, much warmer than normal water working its way east towards the Galapagos Island, 3-4 degree anomalies. This pocket was previously back here and was previously at the surface. And what happened about 2 months ago, we got a lot of westerly winds blowing on the ocean surface, on the equator in the West Pacific. What it does is it takes warm water pulled up there, pushes it down to depth. It works the whole way, it works itself the whole way across under the equator, the whole way across the Pacific Ocean, and then starts erupting up off the Galapagos and off Ecuador. This is what's called a Kelvin wave. Currently, we have a Kelvin wave in flight, getting ready to erupt along the Galapagos. And if you remember the previous animation, what happens is this warm water, when it starts building up off the Galapagos Islands, will then be caught by winds and start, you see, remember those pulses that were working their way east to west across the Pacific? Well, this is another big batch of warm water that's going to build yet another series of pulses going across the equatorial Pacific, and will warm water temperatures there even more. That should fuel the jet stream more, and that is the hallmark signs of El Nino. Now, whether this is a strong El Nino, not so much, because water temperatures are, you know, as we saw before on the surface in this area, 0.5 degree to 1 degree above normal. To put things in perspective, the big El Ninos are 2, 2.2, 2.4 degrees, or even more. So this one is very weak, but it clearly is having an impact on the atmosphere, and that's all we care about from a swell production standpoint. And for those in California, from a rain perspective, it's having the desired effect, and that's good news. Here's another view of the same thing. They use models to sort of fill in the gaps and to sort of round it out. So what do we have? 1, 2, 3, 4, 5, and maybe even 6. 1, 2, 3, 4, 5. Oh, so even a hint of, so basically 4 degree anomalies here, which is what the other chart was showing. This is just a little bit higher res. So anyway, Kelvin wave clearly in flight, working its way towards the Galapagos. And yet there's one more view, satellite view, strip out all the waves, strip out the tides, strip out wind swell, everything, and just how high is the ocean surface deviation from normal for this time of year. And we clearly see a patch of anomalies here in the 0 to 5 centimeter, maybe a little bit, maybe 6 centimeters buried in here. It is these patches that suggest that there's warm water at depth. Warm water at depth displaces the surface upward, and so that's what we're seeing here. Again, just another indicator that a Kelvin wave is in flight, getting ready to erupt, probably in the next 10 to 15 days here near the Galapagos and between Ecuador, and that'll start yet more warm pulses working their way across the equator. Again, helping to fuel El Nino, or at least the jet stream at a minimum. We like this chart a lot because it helps show you historically what's going on. The West Pacific here, the East Pacific here, and this is over time. So January, even back, you can see a little bit here, these reds, these are warmer than normal water at depth. So read them as Kelvin waves. 1 Kelvin wave impacted the East Pacific in the December-January time frame a year ago. A massive one, January, February, March, was generated. It impacted in May or so. Bit of a cool spurt. Then a tiny Kelvin wave, or a weak one, in the September-ish, October time frame. And now here's the Kelvin wave that we're looking at, and it's actually gotten reasonably strong. This would be the second most strongest Kelvin wave over this year. And you don't get Kelvin waves unless you're in some flavor of El Nino, or at least a neutral pattern. If you're in La Nina, forget it. All you see is cold water. No warm water migrates this way. So this is, again, what's helping to fuel the jet stream. This is probably the final Kelvin wave in this El Nino cycle, unless something special happens. This being a very weak El Nino, it's entirely possible that something special could happen. Anyway, so here we go. Final Kelvin wave getting ready to impact, typically by about December 21st, in the December, early January timeframe. That's when El Nino peaks out, and then it sort of falls apart, unless you go into a multi-year event. And finally, projections from the CFSV2 model for the Nino 3.4 region. That's the area we're talking about on the equator between 120 and 170 west. Anyway, water temperatures in that region, and here's about where we are now. Actually, this suggests water temperatures backing off some. That doesn't seem very reasonable, considering there's a Kelvin wave getting ready to erupt under the surface. But still, let's say holding in no less than 5 degrees above normal range into April. And so typically what happens is El Nino goes along like this, and then once you get into about March or April, the temperatures start dropping off. It either returns to normal, or typically if it's a reasonably strong El Nino, you go right into La Nina and temperatures start dropping down into here. But notice this model suggests that we just hold a steady state about like how we are, and then we get into the summer when typically El Ninos get formed. A second wave of this El Nino develops and pushes temperatures up. Wow, this is the latest run, back up to 1.9. Even 24 hours ago, it was only projected down at 1.5 degrees above normal. Now it's back to 1.9. It had projected this a couple weeks ago, backed off. Now it's coming back. So we'll see. Other models are not nearly as optimistic about this, but let's talk for a second. Typically, the sort of El Nino that we're in, this barely an El Nino. You notice NOAA, nobody else is even declaring it an El Nino yet, though Japan did just today. But typically, most agencies are saying this isn't even El Nino. You got to have warm temperatures, warmer than what they are, running for longer than what they are, and we haven't reached the threshold yet. And our thoughts are, if you haven't reached the threshold by the first couple weeks in January, you're probably not going to get there. But that's okay. It's fine with us. This is what they call a Modoki El Nino. Kind of El Nino, but not really. But that's okay, because Modoki El Ninos do have a positive impact on the atmosphere. Certainly notice how the weather patterns in California and Hawaii are much different than they've been for the past 4 years previous. Clearly the jet stream's active. Clearly trades have been suppressed. Clearly water temperatures are above normal, and the storm track has done very well this fall and continues to look to be doing very good. Anyway, that's classic Modoki El Nino, and Modoki El Ninos typically go for 2, sometimes 3 years before they culminate in a full-blown El Nino. And sometimes they fade out and go neutral, then come back. So this suggests that perhaps we are in a Modoki El Nino situation. Perhaps the pattern that we've seen this winter will continue into a year from now, maybe 2 years from now if we're lucky, and that just builds more and more momentum in the jet stream. It not only at that point would help to improve storm production this winter, it might have a positive impact on the southern hemisphere Pacific Ocean, and then if that happens, then also again in the winter of 2015, 2016, we're even better set up. But that's a lot of what ifs. That's a lot of speculation. As of right now, take it for what it is. Things are looking good in the atmosphere, and storm production is on a roll. So for now, swell in the water, about ready to impact California, along with some weather. Swell also hitting Hawaii. Another gale forecast pushing over the dateline into the western Gulf in the next couple of days, and a far larger system behind that more swell coming for the short term. El Nino, Modoki or otherwise, continues to evolve. Another Kelvin wave getting ready to impact Ecuador, which will keep water temperatures warm, and no sign of it really stopping. Yes, the models suggest perhaps a little bit of an inactive phase of the MJO, but we've seen that projected multiple times now over this past year. None of it really materializes. Sure, the jet stream backs off for a little bit, for a week or two, and then comes right back on, and things will pick up. So for right now, the forecast looks quite favorable. Go get some waves. Go have some fun, folks. We'll do this again next week. Same time, same channel. Enjoy. See you next week. Bye.